Hi guys, well we'll get started, so any stragglers who join us hopefully won't miss too much. So Tony Whiting, founding director and founding shareholder very proudly of Raytec. We do have a little bit of history, nearly decades of history in transport applications and the lighting requirements thereof. So we're delighted to share some of our experiences, some of our applications that we've been involved with. I think it's always nice for people to get a little flavour of the company. So if I can get my screen working, bear with me 1 second. A slight technical glitch. Showing. Aha. So a little bit of our heritage and history going back even pre-Raytec days, and I'll give you a brief visual insight into some of these projects, but very proudly involved with one of the first major number plate capture projects that was here in the UK back in 1997. That was Project Glutton. In the early 2000s, we helped develop a average speed check system for the UK motorways, and I think that's been rolled out in other places around the world. I apologise if it has affected you personally, but we just help with the design. We don't deploy these things. Also we were heavily involved in the London congestion charging scheme, but I'll show you a bit of that. But I think it's clear from our history and looking forward that ITS transportation systems are a key growing part of Raytec's business portfolio. So Project Glutton was deployed in Northern Ireland, where there was a particular terrorist threat at the time from the IRA in the late 1990s. And it was fairly cutting edge technology back then, being able to capture, interpret and analyze number plates. And you may wonder why there's a picture of Superman down below that. Well, the guy who we helped to develop this system was actually part of the team that won an Oscar for the first Superman movie for some of his Zoptronic technology. And quite interesting that if he changed away from Hollywood and got into number plates, but that's how strange things happen. But that's a guy called David Speed, unfortunately passed away now, but we worked with him on Project Glutton to roll out 100 number plates in the first major rollout of ANPR. London was one of the first cities to end up with a congestion charge introduced back in 2003, and at the time was the largest in the world. I dare say there's some parts of the Far East now have bigger systems. It was pretty sizable, approaching 1,000 cameras by the end. Major system. I peculiarly actually went to London on the first day of the introduction of the congestion charge, because having been involved in the design and the implementation of the system, I was daft enough that I wanted to pay, then it was £5, and have a picture taken of myself with the photograph on the first day of the congestion charge. So I was the only willing payee that day. And this is a very well-known product in UK. It's predominantly for high-risk roads where they want to have effective traffic calming measures implemented, and also for temporary road work. So in the road works, they'll typically have an average speed requirement of 50 miles an hour, or on dangerous roads they might implement a 60 or 70 mile an hour, approximately 100 kilometers an hour. But I have to say this has been an incredibly successful technology. All drivers in the UK are very aware of these average speed check, where they're measuring the speed of vehicles over long distances. And I have to say it's been phenomenally successful, and we were proudly involved in that in the early 2000s. So hopefully you get a flavour that we've been around the block, we know what we're talking about, and we're here to help. So the agenda. It's always a challenge when you're speaking to customers all around the world, because unfortunately sometimes we're divided by a common language, to misquote somebody. So I've called it OCR, optical character recognition, to avoid the issue that here in the UK and parts of Europe we might call it ANPR, but in North America they might call it LPR. So the difference between a number plate and a license plate. I will fall into the trap later, so I apologise, but we'll call it capturing the plate or getting the plate, so I can avoid those other acronyms. So we'll look at the technical challenges of getting that plate. We'll look at the opportunities of either using pulse lighting or constant lighting. We'll have a throwback to the 1980s and 90s, where you might remember your hi-fi, where you either got an integrated hi-fi or separates. And the same actually applies to ANPR or ALPR systems. So we'll have a little look at that. We'll have a look at some other OCR applications, spin-offs from there, recognizing vehicles, recognizing passengers. We'll have a look at some other ITS applications, hard shoulder monitoring, intelligent motorways. We'll have a look at some safety and inspection stuff on road and rail. We will sell to you for a full 2 minutes and show you some of the Raytec solutions and support that we can offer. And we'll have a Q&A session during at the end. If there are any questions that arise, we do have a text box that you can text your questions into. If they're relevant and I can answer them as I go, I'll attempt to do that. But there'll be plenty of time to have a Q&A session at the end. We had a very healthy, lively debate on this morning's webinar, so it was very useful. Okay, so what are the technical challenges in getting that plate? Well, the top 4 challenges: speed, headlights, lighting conditions, and weather, are common all around the world. They are challenges that we need to face. Motor vehicles going 100 kilometers an hour, 70 miles an hour plus, the glare of the headlights, the glare of the sun, the 100,000 lux on scene when it's sunny, the 0 lux when it's dark, the weather implications, rain and snow. And on the far right-hand side, you can see a typical summer's day in England, where it's rainy, sunny and cloudy on the same day. So those are the common challenges all around the world. But number plates are fairly unique to your own jurisdiction or country. And the variety is so vast that it's very difficult for us to cover it in any great detail. We'll touch upon some of the technology challenges, but it is really so specific that it's difficult to discuss it in absolute detail. But if you do have particular applications and challenges with certain territories, please just contact me directly or any of the sales and tech team and we can talk about it. But that is the biggest variable. The rest are common variables that we all face. So we prepared this slide back in about 2007, 2008, and I counted the number plates this morning. Unfortunately, it's the same number as the date of my birthday, so I remember that there's 27 number plates on there that actually represented the number plates from all our partners who came to visit us for our first Platinum Partner Conference in 2008. But really it's to give you a flavour of the complexity, diversity and differences between number plates across the world. So it's a hell of a challenge for anybody operating on a global basis. Hopefully most of you guys are working in a more localised territory where there's a bit more commonality. I'm going to touch on a tiny little bit of physics, but it is relevant because number plates are fairly unique. So there's 3 main types of reflection, and reflection is important to us because the light that your camera captures is related to the amount of light hitting it and the sort of material and object that it hits. And the most common type of reflection is diffuse reflection, where the light hits the target and is reflected in all directions back. So some of that light will actually go back towards the camera. And that is the sort of reflection that 95% of all materials exhibit. So as you sit in your offices or your homes now, the majority of materials that you're looking at will be diffusing the light that's available back into your eye. So diffuse reflection. At the other extreme, this is the rarest sort of reflection, is specular reflection. And there you can see that the light hits the target object and continues and bounces off in the same direction that it hit the object, and none of the light returns back to the camera. Now, these sort of materials are fairly unique. You're talking about mirrors, very shiny surfaces where the light hits it and bounces off in the same direction of travel. So quite a rare thing. Number plates are somewhere in the middle, and they're not very common, they're not totally rare, but they are retroreflective, which is very useful for us because it means that the majority of number plates, the light that hits them, all of that light returns in the same direction in which it hit the number plate, and therefore you get the maximum amount of light reflecting back into the camera. So if you do normal video surveillance applications, you'll be well aware of when you put infrared or white light onto a number plate, it very often washes out the number plate because such is the amount of power that's reflected, there's too much light in a normal video surveillance application for the camera to be able to handle that. And that is because the majority of number plates are retroreflective. Other retroreflective things are things like roadway signage, because it's very important that the light reflects back towards the car so that you know what's going on. Typically, people working on motorways or cyclists will have highly reflective things at the wear, but they're not only the reflective, they're retroreflective because it's important that the light goes back to from whence it came. So that's number plates. So as I say, most are retroreflective. That does have its pros and cons. As I touched on in normal video surveillance, it's a bit of a con. It's a bit of a negative because it tends to wash out the number plate. But for ANPR or ALPR applications, it's actually a benefit because we're going to see some of the stresses and pressures that are upon an ANPR system, and the fact that there's a high percentage of light is reflected is a great big benefit for us. Some are very difficult, and as I touched upon, there's very big geographic differences. The UK is a bit boring. We're very consistent. We don't allow any differentiation in terms of fonts or materials or vanity plates. It's a bit boring, but it's good from an ANPR perspective. Europe, there's big differences between countries, but within countries, they tend to be fairly consistent. Though Belgian plates historically have been a bit of a challenge to us because of the variety of manufacturing methods that they've used. The United States is really 50 or 51 countries, depending on how you look at it, and they have a very wide diversity of plates. And I know some of my Canadian colleagues are on the call today, so hopefully I've quoted that right. 10 provinces and 3 territories, all with slightly different styles. So it is a challenge. So why is it challenging? Well, so we have to look at the materials that the number plates are made of. Some are made of plastic, some are made of pressed metal, and it's down to the chemistry and physics of the license plate will affect the amount of light that's actually returned back to the camera. So the material has an impact. Clearly the size of the number plate, but weirdly in North America, some states, I think it may be changing, but you didn't necessarily have to have front and rear license plates. So the quantity of license plates can have an impact, but I think as smarter tolling systems take more of a hold in the States, I think that will start to change. The color of number plates is challenging. Red is particularly challenging, but you see the Californian number plate, I think that has at least 4 different colors on it. And if the information is important from a licensing perspective or a location perspective, it can be quite a challenge to choose the right lighting to get a good grab of that picture. And then the font, you can see the left-hand plate there, that's a pretty challenging font. But the right-hand plate is very interesting because the Dutch have been leaders in traffic enforcement cameras. Famously, the GATSO system was developed in the Netherlands, and they've actually enhanced their number plates. If you have a look at the R on the right-hand side of the Dutch number plate, you see they've got a gap in the top of the R, and that is effectively to assist ANPR systems in the Netherlands. They've got quite a few characters that computers may historically have mixed up, so they've added some identifiers to assist the ANPR system. So if all countries were that far-sighted, life would be a lot easier. But what are the key elements of capturing that plate? Well, we have been doing, it is true really whether you're looking at a video surveillance or a machine vision or a license plate capture system, but it all revolves around having a good camera, a good lens, if I can find my mouse somewhere. Filtering sometimes required to improve the quality of that picture, and then essentially good, if not great, lighting. So down the bottom, those of you in the computer world will recognize some of that terminology, but garbage in equals garbage out. So that's the left-hand one. I couldn't possibly comment what the right-hand car says, but we all know that if the quality of the video image is not good enough, any computer or algorithm or software is never going to be able to interpret a poor picture. So the key thing is high quality pictures. So we're going to go through some of these elements, and they do share very similar elements with machine vision in terms of you've got fast moving objects, you've got challenging lighting conditions, and fundamentally you want high quality images at the end of it. So we'll have a look at fast moving images. We've got a fountain here, and we've got two pictures, one showing a camera set at a 15th of a second shutter speed. That's on the left hand side, and on the right hand side a shutter speed of 1/1000th of a second. And you can see the benefits that the faster shutter speed provides. In the left hand picture it looks like a continuous gush of water, it's all blurred, but on the right hand side you can start to pick out some of the individual droplets of water, you can start to see true detail. Interestingly, the brightness of the picture is reduced, and that makes sense because there is less light available, but also the focus and the depth of field of the picture is improved by the faster shutter speed. So we have a faster shutter speed to stop the motion blur, but it has additional benefits too. Yeah, I think this one highlights it excellently, a spinning fan. Unfortunately, I can't tell you at what speed this fan is spinning. And weirdly, the best quality picture is the shutter speed that we would normally recommend for ANPR applications. So maybe it's going pretty much the same speed as a car. But you can see the effect of freezing a video picture at those different shutter speeds, the effect of looking at those fans. In the 1/8 of a second, there's too much time elapsed. The fan is moving too quickly, so it looks blurred. And then you go to the opposite end of the spectrum where at 1/1000th of a second, that fan is spinning at the same speed as the 1/8 of a second picture. But if you freeze the picture because of the fast shutter speed, then it totally and utterly freezes the fan. This gives you an impression of the effect of the shutter speed, not on stopping the motion of an object, but on the amount of light that's passing through to the camera sensor. So bottom right, the only thing that's changing here is the shutter duration. So bottom right, you've got 1/2 a second shutter, and top left, you've got 1/250th of a second. You can see that the 1/2 a second picture, it's over illuminated, it's glary, it has no focus whatsoever and no depth of field. And as you progress through, by the time you've got through to, let's say, 1/30th of a second shutter, so that's the top right hand, you're in focus, there's no glare, you can see what's happening, and after a 30th of a second, you're actually now no longer have enough light to get a good picture. So you've gone from a half a second too much light to a 30th of a second the right amount of light. Beyond that, you haven't got enough light. But you can see the effect of having a faster shutter speed significantly reduces the available light to you. So imagine you've got a car traveling at 70 miles an hour or 112 kilometers an hour. A typical video surveillance camera working at a 50th of a second shutter, that car will have moved, I just have to move my screen to check, 62 centimeters. Each frame of video, 24 inches. And that's why it gets too blurry for the operator or the computer to be able to interpret. If you change your shutter speed to 1/1000th of a second, that number plate per frame only moves 3 centimeters or a touch over 1 inch. And that's why you're able to freeze that motion. That's why you're able to get that crystal clear shot. So that shutter speed is really helping you accommodate the speed of the vehicle. The faster the vehicle, the faster the shutter speed, but if they're going more than 100 miles an hour or 140 kilometers per hour, hopefully the police are going to deal with them directly rather than the ANPR system. Unless, of course, you're in some parts of Germany where you can drive as fast as you like. So in summary, the difference between those two setups, a camera running at 1/50th of a second in normal mode compared to a camera running at 1/1000th of a second, there is 20 times less light for the ANPR camera to work. 20 times less light, or you need 20 times more light to produce the same level of picture. So it's very dramatic. You need it to capture your speed, but it does affect the amount of light that you fundamentally need on the scene. So the next lighting challenge is lens aperture. So on the right-hand side, hopefully you can see the diaphragm of the lens getting smaller and smaller as you move between the f-stops. And hopefully these are the proper full f-stops here. So for every f-stop that you'd move, you change, you half the available amount of light. So an f1.4 lens, this is how I remember it. The amount of light that a lens transmits with relation to the f-stop is 1 over the f-stop squared. I know it sounds like a horrible bit of maths, takes us back to school a little bit, but actually it's not too tricky. So the 1.4 f-stop, 1 over 1.4 squared is actually a half. 1.4 times 1.4 is 2. And if you compare that to an f2 lens, 1 over 2 squared is a quarter. So I've moved 1 f-stop, so I've moved from half the amount of light to a quarter of the amount of light. I've exactly half the amount of light. 1 over the f-stop squared is a very useful little mnemonic to remember. Interestingly, so you can see the dramatic effect that f-stop has, because if you go to an f8 lens, f8 f-stop, you'll get 1 over 8 squared, or 1/64th of the available light through. So changing your f-stop has a lot of benefits that we'll see, but also significantly reduces the available amount of light. But why do we need to close the f-stop for ANPR applications? Well, we're fighting the effect of the car headlights. They're potentially burning the camera, glaring it, so we need to close the aperture to fight against the headlights. Potentially we're fighting against the sun and the location of the sun and the reflection of the sun off other items, so we need to close the aperture. Photographers will tell you that closing the aperture as much as possible gives you the best chance of a good depth of field and a better focus. So we want to close it as much as possible for those reasons, but it does deliver you significantly less light to your camera. And here's another visual. This time we're not changing the shutter. This time we're changing the f-stop, but it actually has the same effect. Top left to bottom right, you're going from f1.8 to, can't see it, f22. And you can see that f1.8, potentially too much light getting through, slight bit of glare, poor focus. Interestingly, round about f5.6, f8, so the bottom, top right and bottom left, you're getting a really good sharp image, good focus, good depth of field. After that, by the time you get to f11, you actually haven't got enough available light to get a good picture, so the aperture has become too small for that application. But the message is the same. You need more light. And this is quite I made a terrible joke this morning about this being a bit of a twee graphic, but I'm not sure it'll work again. But it shows the effect of depth of field. So the top camera lens is set at f1.4, and it focuses perfectly on the one, I don't know what that is, parrot or phoenix on the tree, but lots of other things are out of focus because it's a the camera aperture is wide open. If you go all the way down to the bottom, f22, the depth of field now is massive. It's all the way from the front of the tree to the back of the tree. So that is the benefit for us. We get less light is a disadvantage, but we get better focus and better depth of field as a result. And that's just another way of showing exactly the same thing. But if typically in CCTV, video surveillance, if you're setting your camera lens at f1.4 compared to ANPR setting your f-stop at f5.6, you've got 16 times less light. You've moved 4 f-stops, which means you've got 16 times less light, or again, you need to put 16 times more light on to achieve the same effect. And those two effects of changing your shutter speed and changing your aperture are cumulative and act in tandem together. So actually the maths is horrific, that if you're running a fast shutter speed and you've got a high f-stop, you've got 320th of the light compared to a standard shutter speed and a standard aperture, or you need 320 times more light. So it sounds like we're trying to sell you a lot of lights. That's what we're here for. But unfortunately, the math supports us and the physics supports us. But there's some good news because of the retroreflectivity of the number plates or the license plates. But it's always important to consider your application for ANPR. Some are more critical than others. If you've got an access control system like this one, where they've deployed our Vario systems at Heathrow Airport, the implications of that access control system, parking control system not working is pretty horrendous. So they have to be absolutely sure that the quality of that image is perfect, and you cannot risk garbage in, garbage out. It's got to be perfection in and perfection out. So here at Raytec, we've been using the same formula for about the last, certainly 13 years here and more previously. The physics hasn't changed. Some of the technology's changed, higher resolution cameras, better lenses, better lighting, but the fundamentals are the same. And this is what we recommend to clients if they ask for our advice. We would tell them to run a shutter speed of at least 1,000th of a second, more in higher speed applications, but at least 1,000th of a shutter speed, at least an aperture of f5.6 and more, and the more you can close that aperture, the better your picture, but the more light you need, so it's a compromise. Set your gain on your camera to the minimum that you can get away with. The less the gain, the less the potential noise. So typically we might be as low as 18 dB, but we might try go even lower if we can get away with it. We set the gamma to 1 to maximize the contrast between the white of the number plate and the dark of the letters. We'd use a narrow band pass filter. We won't talk about that too much, but it's effectively a filter that exactly matches the illumination from an LED illuminator. So it effectively means you don't lose any of the potential power output from your illuminator, but the narrow band pass blocks all other unwanted light sources, so helps reduce the effect of the sun, glare from headlights, reflections, etc. So we find that quite powerful for clients if they've got a real issue with getting the plate. And obviously we talk all the time here about the quality, the quantity, and the wavelength of light that you might require for your particular application. So that is the Raytec magic formula that's stood us very well for lots of different installations and applications around the world. So in summary, shutter speed, you need more light. Aperture, you need more light, because fundamentally you need high quality pictures for that system to work correctly. So that's we'll touch a little bit on pulse, the benefits, pros and cons of pulse versus constant light. At Raytec, we're totally agnostic. We don't mind whichever route a client chooses to go, because we provide both solutions. So it's not a question of we push one technology over another. We prefer our clients got exactly the right technology. Constant lighting may be easier to set up, may be easier to maintain, because everybody understands the concept of a light that's always on. But pulse lighting does provide us some opportunities and some benefits that we need to consider. So what are those benefits? Well, you can get more power output by pulsing your LEDs. Light emitting diodes are very comfortable being pulsed at higher power for a shorter duration. And you can get up to 5 times the power output from an LED, because of the fact that you're only turning them on for effectively 1 millisecond every 20 milliseconds. Gives you this opportunity to overdrive them and to pulse. As a result of the fact that you're only turning it on 1 millisecond out of every 20 or 2, then there's a significant power usage saving, and this can be as much as a 20th of the power can be getting used. So you're saving 18 or 19 20ths of that power. So that's quite a benefit, particularly if energy source is scarce. The fact that your light is pulsing means it's off more than it's on, so that has a benefit in terms of a lower operating temperature. So if you're operating in a higher ambient, the fact that your light is running at a lower operating temperature is a benefit. And obviously potentially has beneficial effects in terms of reliability, etc. And particularly with white light units, there's the opportunity to reduce the visual impact of the unit. If you're pulsing it, it looks visibly less bright as a result of the fact that it's pulsing. So they're all operational benefits, but also there's some functionality benefits that we need to consider. So with a pulse system, you can effectively create different power levels with the same light. And why would you want to do that? Well, maybe you're seeing lots of variation in number plates, so you might want a high power flash, a mid power flash, and a low power flash to ensure 100% that at least one of those flashes gives you a good result. You might be sitting on a county border in the States where you have cars from lots of different states that have different power level requirements. So pulsing might give you that opportunity. I saw a very nice application, one of our partner companies, where they were using the pulse system to get the number plate, but also to get some details on a permit that was installed on the car. And because of the different reflectivity of the number plate and the permit, they needed 2 different power levels, and the pulse capability gave them the opportunity to program exactly what they wanted. So you can have different power levels. Potentially you could have different wavelengths of light also. So this gives you benefits potentially if you want to look at passenger recognition. So you might use one wavelength for the number plate, and you might need a different wavelength to look through the car windscreen. So different wavelengths give you opportunities. So there are increased functionality benefits from pulsing. It's a little bit more of a complex installation, but obviously if you've got operational demands or functionality requirements that you need it, and we're obviously very happy to help and discuss. So this is going to split the crowd in terms of age and sex. So I know we do have a variety of people with us, but if you're under 40 and probably non-male, some of this might not make sense, because back in the 80s and 90s, men used to spend waste a whole load of time discussing the merits and benefits of all-in-one hi-fi versus separates. And only men were daft enough to spend that amount of time discussing something that really wasn't that important. But the same concept really exists in the ANPR world, because you have effectively all-in-one cameras, or you have separates. And some people prefer the all-in-one approach, just like the hi-fi system. It's more straightforward, it's more simple, everything is there. The purists may prefer the separates approach, where they can specify every bit of equipment, or there's operational requirements, or they're using third-party software. So I've tried to highlight some of the reasons why I think people might consider separates. There's no right or wrong answer, but obviously they can do a custom design that commercially might offer them some protection, increased flexibility, in terms of the components that they can choose. They can choose the best quality component, the best camera, the best lens, the best light. So it gives them a bit of flexibility. There may be more demanding applications involved in terms of longer distance, higher ambient temperature, more difficult number plates to read. So there may be a good reason to go away from the all-in-one concept. There may be specification requirements in the A&E spec, or there may be functionality that the camera offers in a separate situation that an all-in-one doesn't offer. There are people out there offering third-party software that might not be offering third-party hardware, so you might want to develop your own system. And there's the potential for reduced maintenance costs in terms of you could replace single elements of the system without replacing the whole camera as an all-in-one. But there's just some reasons why people might consider going down the separates route. So in summary, we've looked at the challenges of capturing the plate. Hopefully we've provided some solutions to that. We've hopefully emphasized that it is a total systems approach in terms of camera, lens, lighting. Lighting for us is at the heart of it. There's some setups that you can do in your camera. There's things that you can do with your lenses, but they're effectively off-the-shelf components. I think there's a lot more flexibility, variety that you can get from your lighting piece of the solution. We've hopefully looked and discussed some of the pros and cons of pulse versus constant, and had a brief look at all-in-one versus separates. So we'll briefly run through some of the other applications that we talked about. So ANPR was part of that optical character recognition piece. So here's another couple of ones to share with you. This one was particularly interesting. This was on the French railways, the Société Nationale Chemin de Fer, and they had a particular high-speed application. So their trains would be running far in excess of the speeds of cars. They also had we need to go back up there. They had a non-retroreflective sign. So if it had been retroreflective, more of the light would have come back. But the fact that it was high speed and the fact that it was non-retroreflective meant we had to deploy a lot more lighting than we normally would have done. So you can see 1, 2, 3, 4 of our double lighting units, either Vario or Polestar. I think they couldn't integrate with the camera in this case, so they had to use standard Vario. And I suspect it was also had to be 940 nanometer because with the proximity to the railway, they didn't want to cause any potential for misinterpretation between the red glow of an 850 nanometer and a traffic stop sign. So that's why you've ended up with a lot of lighting. It's a higher speed application, so the shutter would have had to be running even faster, which meant there'd be less light. It was non-retroreflective, which means less light was coming back to the camera, and that's why we ended up with 4 illuminators. I think this was a trial site, hence the sort of state of the installation that you see. But that trialed very successfully, and you can see the quality of the graphics that they were trying to read on the front of the train to identify. So that worked very, very well for them. This was a pretty major scheme rolled out across many UK ports. It wasn't just a container recognition system, it was a detection system. So that is a fairly high-end piece of equipment, big yellow and white thing. But on there we deployed some of our white lighting and infrared to assist them with reading the characters on the side of the container. So there were some challenges there in terms of a wide variety of different colours of container and lettering used. So we ended up using a white light system for that, I think constantly on because it was relatively short range, but that was rolled out again across most UK ports. We said we'd touch on a little bit of vehicle recognition. So this is the average speed check system. So on the left, you can see, hopefully, if I can find my mouse, yeah. So on the left of the system, we have 5 Vario white lights that are used at night to provide a good color image of the car. And it's quite a narrow beam pattern that's produced, and it's not going terribly far. So for a normal video surveillance application, we would probably say that you would only need 1 Vario for that application. But again, the camera is not co-located with the lighting. The speed involved, they'll be setting the shutter speed high and closing down the aperture on the camera, so they've needed more lighting. And obviously they've had to locate the lighting off axis from the driver to avoid glaring them. So that's why they've ended up with 5 Varios on the side of the road, but that works very well in the UK. This is a big thing in North America at the minute, the use of roads, and I think it's going to start to have more impact in UK and Europe. So they have things called HOVs and HOTs, so high occupancy vehicle and high occupancy tolling. But you can see some of the infrastructure that's had to be deployed here. If I can find my mouse again, if it comes back to life, here we go. Where has he gone? So if you look across the top of the road, you can see some cameras, there'll be transponders, but also lighting. But on the side of the road also, in order to get a side view into the vehicle, they've had to deploy some pretty meaty lighting systems to be able to look through it. And this is the sort of results. And these are big companies who are looking at installing these things. People like Xerox and Siemens are developing these systems, but these are pretty high-end, high-power systems. But you can see the amount of light that's required, not just to provide an image of the front driver, but also for the high occupancy toll. So if you have more than 2 or 3 people in your car in the States, you can potentially pay a lower toll or pay no toll as a result. But obviously they need to police and enforce that. So there's some pretty sophisticated systems out there. A couple of ITS applications. This was hard shoulder monitoring in Denmark, so more of a surveillance and security aspect. This was the UK one. This has been rolled out on probably hundreds of miles in the UK, where they have a couple of our i8-3 products and an i8-1 product on a movable camera, and they're using that to do hard shoulder monitoring to see whether they can use the hard shoulder in peak hours to clear the hard shoulder, so it will be integrated with vehicle messaging signs, whether they need to clear the hard shoulder as a result of an emergency vehicle needing to get access. That has been rolled out and deployed on many UK roads successfully. Rail monitoring, we've been involved in monitoring the pantograph at the top of the railway that connects to the power lines. This one is monitoring the actual rolling stock, but was also increasing demand for monitoring of the actual rail infrastructure itself. So we're seeing higher and higher demand for rail monitoring systems. And this is up in Bonnie, Scotland somewhere, where they're using robotics cameras and Raytec infrared lighting to check the road surfaces. You can tell by the backdrop it's probably a pretty challenging part of the world, so they needed to deploy some pretty good cameras and lighting to keep an eye on that in a remote location. Okay, it would be unfair to allow you to escape without at least subjecting you to some Raytec solutions and support, but we'll go through these pretty briefly because hopefully most of you guys are pretty well versed on it. So as I said, we are agnostic. We don't care if somebody wants to go down a constant lighting solution or a pulse lighting solution. We have both available. So our lead product, constant light, is Vario 2, available white light, infrared and hybrid. It's state-of-the-art, tried and tested technology, tens, if not hundreds of thousands deployed around the world. So it's field-proven technology. Multiple angles, all from the same unit. It's the state-of-the-art in video surveillance, and we also believe ITS2. So that's Vario 2. Polestar is our recent release to target this market. So available in infrared and white light, but also fundamentally you can mix and match those wavelengths. We have systems that have up to 4 control channels. So effectively you could have 4 independent lights being pulsed in different ways for a variety of reasons, but provides very high intensity pulsed illumination. You need to synchronize it with your camera to get the most benefits. So typically your camera would need a TTL output for you to be able to exploit the benefits of Polestar. I'm not sure about how many video surveillance cameras have a TTL output. Many of the machine vision type cameras that are coming into our market do, so the likes of Luminera, Basler, etc. As I say, you've got individual illuminator control from your 4 channels of your largest Polestar unit. Very proudly, we launched our IP-based products probably about 4 or 5 years ago now, but these are the lead IP products in the video surveillance market. Smart and programmable units that you can control individually or control in groups. They've got an integrated web interface in the unit, so you can communicate directly with it, or you can integrate it within your VMS or BMS environment, or indeed you can send HTTP commands to take total control. So a highly powerful, highly flexible, highly programmable unit. Again, available white light, infrared and hybrid. Partly as a demand from the transport markets, some of the certification requirements, some of the operational requirements of traffic are pretty intense. So some of our bigger customers will ask about certification, vibration, salinity, humidity. So as a result, we've recently launched a range of extreme illuminators designed for the most punishing and challenging applications, and traffic and transportation is certainly one of those. You get the same high performance, reliability and support, but all in an extreme package. And I guess comes back to the all-in-one versus separates discussion. We do have a solution if people want to use their own camera, but we can help them integrate it into a housing together with integrated lighting. So that's our VLK system, full lighting housing system into which people can integrate up to 2 of their own cameras, IP, or is anybody using analog? I'm not sure. Available in white light and infrared, but that has been deployed for quite a number of our customers for their own ANPR applications. A hint of some of the support that we can offer you guys. Obviously, we have our lighting design team, pretty industry leading in terms of capability. But I can show you one of the designs, a real life design on the next slide, but we can do 2D and 3D designs to assist. We've got a very simple ANPR calculator that goes through some of the shutter speed, the implications of changed shutter speeds and changed apertures. So that's quite a useful little reckoner to get an understanding of the implication on light, the lighting requirements. In the normal Raytec way, we'll fully support you with demo units. We want you to experience that performance and capability, but we know ITS is challenging. It's not always 100% obvious what you require at the outset. So we do think that a try before you buy scheme, a demo unit is very important. Get your hands on it. And we're very happy to discuss any custom build, any strange wavelengths, angles, distances. Sadly, we love to talk lighting. It's what we do most of the time. So we do like the odd challenge coming our way. This is an example of an MAOD access port. It's pretty high security. So we did some 2D and 3D lighting designs for them. So you can see what it should look like according to the CAD. And the reality is pretty damned close, and that was for under vehicle and side vehicle inspection. And as you can appreciate from the amount of lighting deployed there, it was a pretty highly secure site that they wanted no mistakes, no errors on. So that gives you a flavor of our lighting design capability. And the good news is that we've all made it in one piece to the end of this road.